Hello everyone, in this video we're going to explore complex numbers. Now first we're going to talk about the definition of complex numbers. A complex number is a number of the form a plus bi, where a and b are real numbers. Note that I equals square root negative 1. A is the real part, b is the imaginary part. Now, if we square this guy, both sides, it turns out to be I squared equals negative 1. In order to add or subtract complex numbers, we just add or subtract the real parts and the imaginary parts separately. So look at this one right here, a plus bi plus c plus di. Now we're going to add two complex numbers. We're going to add the real part, a plus c right here, and imaginary part b plus d. We're going to factor I out, so it could be like this, right? Now we do exactly the same thing for subtraction, right? Now in order to multiply complex numbers, we just FOIL them and note that I squared equals negative 1. So look at this one, we just distribute this, right? And a times c, it could be this guy, a times di, it could be this guy, bi times c, it could be this guy, and bi times di, which is bd I squared, right? Now the real part is this guy and this guy, because I squared equals negative 1, right? So we have ac minus bd, and the imaginary part is this guy right here. We factor I out, so it could be this, right? Now the conjugate of a complex number z equal a plus bi is z bar equals a minus bi, right? Now in order to divide complex numbers, we just multiply the numerator and denominator by the conjugate of the denominator and use the formula a plus b times a minus b equals a squared minus b squared. This guy is the difference of two square formula, right? So look at this one, a plus bi over c plus di. We want to divide this guy. We just multiply the top and bottom by this conjugate, right? So it could be c minus di, right? And we just distribute them, right? Now every complex number a plus bi can be represented as a point or a vector on the complex plane. The horizontal axis, we call this a real axis, which is this one right here, shows the real part a. The vertical axis, this is called imaginary axis, which is right here, show the imaginary part b, right? So suppose if I have 3 plus 2i, right? 3 is the real one, right? So look at the x-axis, 3 right here, right? 2 is the imaginary part, right? So I'm going to count up 2 units, so it could be right here. We're going to talk about the magnitude of a complex number. The magnitude, in other words, the modulus of a complex number z equals a plus bi is its distance from the origin in the complex plane, right? So which means, for example, I have the complex number right here, the distance from here to here is the module of complex number, and is calculated as the square root of a squared plus b squared, right? Now example number 1, write each expression as a complex number in the standard form a plus bi, right? So we need to multiply this guy out, right? So 2 times 3 equals 6. 2 times negative 5i is going to be negative 10i. Negative 2i times 3, negative 6i. And negative 2i times negative 5i is going to be plus 10i squared, right? Now we're going to simplify this guy. Observe that I squared equals negative 1. So this guy turns out to be negative 10, right? So 6 minus 10 is going to be negative 4. And this one is the real part, right? Now imaginary part is right here, right? We're going to simplify this one. It's going to be negative 16i, right? Now question B. We're going to distribute the first two guys right here first, right? So we have 6 minus 2i plus 3i minus I squared, right? Multiply by 2 minus 3i. Now we're going to simplify this guy. I squared equals -1, so this guy turns out to be 1, right? So it could be 1 plus 6, it could be 7, right? Negative 2i plus 3i is going to be 1i, right? And then times 2 minus 3i. We distribute this one more time, right? So it's going to be 14 minus 21i plus 2i minus 3i squared, right? Now we're going to simplify this guy. I squared equals -1, so this guy turns out to be 3. 3 plus 14 is going to be 17, right? And this guy turns out to be negative 19i, right? Now question C. We have negative I, and then we're going to use the complete square formula for this guy. It's going to be 1 plus 2i plus I squared times 2 plus I. Now I squared equals -1. -1 and 1 right here becomes 0, right? So I only have negative I times 2i is going to be negative 2i squared, right? Times 2 plus I. I squared equals -1, so this guy turns out to be 2 times 2 plus I, right? Now we're going to simplify this guy. It turns out to be 4 plus 2i, right? Now question D, we're going to divide two complex numbers, right? So we're going to multiply the top and bottom by this one conjugate. It's going to be 2 plus I, right? Now we distribute the top. It's going to be 12 plus 6i minus 8i minus 4i squared divided by 2 squared minus I squared, right? We're going to use different of 2 squared, right? So the top becomes 12. Observe that I squared equals -1, so this guy turns out to be 4. 4 plus 12 could be 16, right? 6i minus 8i is going to be -2i divided by 4 minus -1, right? So it could be 16 minus 2i divided by 5, right? Now we need to rewrite this one in standard form, right? So it turns out to be 16 over 5 minus 2 over 5i, right? Now question E. We're going to simplify the numerator by adding two complex numbers, right? So 9 plus 3 it could be 12. -4i plus 8i is going to be plus 4i divided by, we distribute this guy. So it could be 24i minus 12i squared, right? So it could be 12 plus 4i divided by 24i. I squared equals -1, so this guy turns out to be plus 12, right? So we need to multiply the top bottom by this guy conjugate, right? Now we distribute the top. 12 times 12 is going to be 144 minus 12 times -24 is going to be -288i, right? 4i times 12 is going to be 48i, and 4i times -24i turns out to be -96i squared, right? Now the bottom becomes the difference of 2 squared, right? So 12 squared is going to be 144. Subtract 24i squared. It's going to be 576i squared, right? Now we're going to simplify. The top becomes 144 plus 96, right? It's going to be 240, right? -288 plus 48. It's going to be -240i divided by I squared equals -1. So 144 plus 576. It's going to be 720, right? Now we're going to write this one in the standard form. So it could be 240 divided by 720 minus 240 divided by 720i. So we're going to simplify. It's going to be 1 over 3 minus 1 over 3i, right? Now let's move on to example number 2. We're going to find the magnitude of the following complex numbers, right? So it's going to be square root of 6 square plus 7 square, right? So it could be square root of 36 plus 49. So it could be square root of 85, right? Now question B. It could be square root of 5 square plus square root of 6 over 7 altogether square, right? So it's going to be square root of 25 plus 6 over 49, right? It's going to be 1231 divided by 49. And then we're going to simplify this one. It's going to be square root of 1231 over 7. Now let's move on to example number 3. Now, suppose we have I, right? If we keep multiplying by I each time, it turns out to be I squared, right? And this is I cubed. This is I to the 4. And this is I to the 5th, etc. Right? Now, we just rewrite this one, right? I squared actually negative 1, right? I cubed is going to be negative 1 times I is going to be negative I, right? And I to the 4 is going to be negative I times I is going to be 1, right? And I to the 5th is going to be I. So this guy the same, right? Which means it's going to be repeating every 4, right? We're going to take 44 right here. We divide by 4. It's going to be 11 and remainder is 0, right? So 44 can be written as congruent to 0 mod 4, right? This one tells us that 44 divided by 4, the remainder is 0, right? So I to the 44 is the same thing as I to the 0, which is 1, right? Next one, 50 divided by 4, you get 2 as the remainder, right? So I to the 50 equals I squared, right? Right here. And it's going to be negative 1. Now 74 congruent to 2 mod 4, right? Because 74 divided by 4 is going to be 18 and remainder 2, right? Then we have I to the 74 is the same thing as I squared, right? And it's going to be negative 1. Now 109 congruent to 1 mod 4, right? So I to the 109 is I to the first, and it's going to be I, right? And the last one, 61 congruent to 1 mod 4, right? Because 61 divided by 4 is going to be 15 and remainder is 1, right? So then I to the 61 equals I to the first, and it's going to be I, right? So we're going to go back over here. I to the 44 equals 1 right here. I to the 50 equals negative 1. I to the 74 equals negative 1, and you have negative 1 becomes plus 1, right? I to the 109 is going to be I right here, and you have negative side right here, so it could be negative I, right? I to the 61 is going to be I right here, plus I, right? So we're going to simplify this one. The answer is 1, right? Now question B, similar to question A, right? So we have 24 congruent to 0 mod 4, right? So then I to the 24 equals I to the 0 is going to be 1, right? Now 56 congruent to 0 mod 4, right? So then I to the 56 is I to the 0 is going to be 1. Now 98 congruent to 2 mod 4, right? And then I to the 98 is the same thing as I squared equal negative 1, right? Now 108 congruent to 0 mod 4, right? Then I to the 108 is I to the 0 and it's going to be 1, right? The last one, 32 congruent to 0 mod 4, right? So then I to the 32 is I to the 0 is going to be 1, right? Now we go back over here. I to the 24 is going to be I to the 0 equals 1 right here, right? I to the 56 equals 1 right here. I to the 98 equals negative 1 right here. I to the 108 equals 1 right here, and you have negative side right here, so negative 1, right? I to the 32 equals 1, and you have negative side, it could be negative 1, right? So if we simplify this one, the answer is negative 1, right? Now let's move on to question C. Now the first root right here is going to be I minus 1, right? Minus I plus 1, right? And this guy actually 0, right? Now the second root right here, we just factor I to the 5th out, right? So it can be I plus I squared plus I cubed plus I to the 4, right? And again, this guy turns out to be I to the 5th times 0, right? It's going to be 0, right? So the cycle repeats every single 4 terms, right? So observe that the sum of every single 4 terms is 0, right? Now we have I to the 100. So we're going to take 100 divided by 4. It's going to be 25 full cycle, right? But each cycle has the value 0, right? So we have 25 times 0 is going to be 0, right? Now question D, similar to question C. Observe that the sum of every single 4 terms equals 0, right? So we're going to take 210 divided by 4. And then we get 52. And then remainder is 2, right? So this guy is the same thing as 210 congruent to 2 mod 4, right? So then the sum of 52 cycles is 0, right? Then we have the leftover right here, right? So the leftover is I plus I squared, which is I minus 1, right? This one is the final answer. Now, example number 4. Show that the complex conjugate of the sum of two complex numbers a plus bi and c plus di is the sum of their complex conjugates. Now the sum is a plus bi plus c plus di, right? So it could be a plus c plus b plus di, right? Now the conjugate of the sum is a plus c minus b plus di, right? Now the sum of the conjugate, so we're going to take the conjugate of this one, a minus bi plus c minus di, right? So it could be a plus c minus bi plus di, right? So it could be a plus c minus b plus di, right? This guy, the same, right? So this guy has been proved. Now question B. The complex conjugate of the product of two complex numbers a plus bi and c plus di is the product of their complex conjugates. So we have the product a plus bi times c plus di. It's going to be a times c plus a times di plus bci plus bdi squared, right? Now we're going to simplify this one. It's going to be ac minus bd, right? Because I squared equals negative 1 plus ad plus bci, right? Now we're going to take the conjugate of this one. So it's going to be, now we're going to take the conjugate of this one. It's going to be A minus B I times C minus D I. We're going to multiply this one out, right? So it could be AC minus ADI minus BCI plus BDI squared, right? We're going to simplify this one, so it's going to be AC minus BD minus AD plus BCI, right? And this guy, the same. So this guy has been proved. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.